So it looks as though it's 8 o'clock here. So good morning, everybody, for this early session on the third day of the DevDays. I'm calling in from Cologne, and our speaker today, Revathy, is calling in from Bangalore, where it's noon right now. And I guess some of you are calling in from the States, where it's evening. So without further ado, I will pass on to Revathy so that she can start this talk on fine-grained access to health data, discussing CDA documents via IHE and the QEDM profiles via FHIR. So I'll just pass on to Revathy.
Yeah, thank you, Gustav. I'll just quickly share my screen.
Exactly. So people are still entering the room, but it's okay.
Yeah. So, Gustav, just a quick check. Are you able to see my screen?
Yes, it's perfect. I can see it.
Okay, yeah. Okay. Good morning, all. Good afternoon, in case you're joined from India and other Southeast Asian countries. I am Revathy Sreenath, and the topic for today's tutorial is how do we access fine-grained discrete data from shared CDA documents via FHIR, and how we use the IHE, MXD, and QEDM profiles as a foundation to enable this. So this is the topic for today's tutorial. A quick introduction about myself. I am Revathy Sreenath. I work as a product manager for Philips HealthSuite Interoperability and Data Platform. I'm joined with me by my colleague Kajal as well, who works as software. So I come with 15 years of healthcare experience in different roles as architect, developer, and product manager. Okay, so moving on, the agenda for today's tutorial, a quick update on that. So firstly, we will touch upon a little bit on the healthcare ecosystem. What is the problem statement that we were trying to address? What was the need that actually resulted in us implementing a specific capability? How we build that capability of data transformation via the IHE QEDM and the IHE MXDE profiles. We will do a little bit deep dive on both of these IHE profiles. We will also learn about a little bit of interconnections that exist between these two profiles. We will also pick a sample use case or an example and try to apply what we have learned from the profiles perspective. And we conclude through the challenges what we faced and what is that changes that we need to bring about. So this is the agenda for today's tutorial. So let's get started. As we have seen in multiple sessions across past 2 days and over the healthcare care continuum as well, healthcare is indeed a complex ecosystem. Complexity and variability are two paradigms of this healthcare ecosystem. So where the data resides, what is the data structure, the data formats, the multiple formats that exist, which different products use and interoperate with it, variability and complexity in terms of data definitions, and also from the regulatory perspective, where we actually bring about these products and solutions into specific different markets that span across different countries. In fact, there is no one digital front door to access data in this whole healthcare ecosystem. Because of the multitude of products that exist, the multitude of specifications that each of them support, be it DICOM, be it FHIR or HL7, or the XDS or the cross-document data sharing profiles governed by IHE. So that's what we would actually touch upon today and learn about a specific use case that we had to work on in such a variable healthcare ecosystem. So the problem statement for today's discussion, was that if you see in different markets across North America or European markets, traditionally the documents get shared via the CDAs, be it from the EMR, across different departments in the hospital, or across different enterprises in an integrated delivery network, or via a healthcare information exchange. CDA documents have been used actually as a source of truth for multiple healthcare information related to patient. So in all these ecosystems, there is a good amount of investment and infrastructure that already exists, which provides capabilities to ingest the data which is coming in the form of CDA documents, or display the data that exists in these CDA documents. Now, that's about the CDA world or the document world. Now we have the FHIR world, where we also need to enable the accessibility of these documents to patients themselves or care providers, or to that matter, any mobile applications or FHIR consumers or lightweight FHIR consumers. So that's where the FHIR standard or the FHIR world comes into play. So the problem statement what we had was actually to bridge between the CDA world, where we already have good amount of data that exists in different data silos, or across a healthcare integrated delivery network or a national network. And how do we enable that data that already exists and enable the reuse of that data to trigger or to build newer workflows, or maybe you could call it flows based on this data. So that was the need that came in. So to summarize on the need, what I mentioned, the idea or the necessity was actually to leverage on the existing infrastructure and investment that we already had in CDA-based infrastructures, and how we could maximize the value of the data that exists in all. The other aspect also, even to this day, good number of EMRs share their data as CDA documents in North American markets, or to that matter in some of the European markets as well. The other aspect was we wanted to leverage on this data that exists in the documents to build newer clinical workflows, where we enable this data accessibility in a further simplified way via FHIR. In fact, in most of the markets, if you see, right, there is also a regulatory need that is coming in, where we need to enable the accessibility of the data that exists within the healthcare provider ecosystem to the patients themselves or to the providers. So in fact, different countries have different regulations on that. An example could be the Medmij on the Netherlands, or that could be, or the equivalent could be the Cures and the CARES Act in the North American markets. Or so that's a little bit about the need as being how do we bridge the world of the CDA documents and the FHIR world, and enable a simplified data access to all the data that exists in the existing infrastructure. So for that, what we did was we actually looked up for a few guidelines on how we could approach this. And one of the important guideline is came in the the query for existing data for mobile. In fact, if you could see, that's actually an extension of the existing QED IHE profile, which defines or provides a capability of querying the data within the XDS network. So we leveraged on this particular profile to build upon the capability what we intended to. So what exactly is this profile? So this profile actually supports querying of clinical data elements that exist in different data stores. Could be an XDS or a cross enterprise data sharing storage, or to that matter, any data storage in FHIR formats. So QEDM is actually functionally equivalent to QED. And in fact, QEDM also provides something called as a document provision option. So as a prologue to this session, I'm not maybe if you have already attended sessions of Rick on 17th and a session of Oliver, where in fact, both touched upon some of the important features of the document. Okay, like for example, wholeness, providing a clinical context, and all those aspects. So, with that intent, the QEDM profile also, via the document provenance option, enables us to link between the source document, that is the source CDA document, and the FHIR resources out or transformed the CDA data into. So in fact, this is actually the link that exists between the source document and the FHIR resources that we have actually extracted from the CDA document. I will touch upon this in a little more detail as we go through in today's session. So from the QEDM profile point of view, the profile actually defines two actors. One is the clinical data consumer. You could attribute this to be a FHIR consumer, could be a mobile app used by a patient or a care provider. And the other important actor is actually a clinical data source, which you could attribute it to a FHIR server. So, and the transaction, what the profile defines is it's a simple FHIR-based query to retrieve the data from the FHIR server, and in fact, the transaction is nothing but PCC44. That's what the spec defines. So, from the actors where the clinical data source can store information related to observations, allergies, conditions, diagnostic results, or any of the information that it could store. And it also provides a mechanism of mapping this information to an equivalent FHIR resource. So as on today, the QEDM IHE profile roughly defines these resources based on the querying capability that already existed in QED IHE profile. So when I say map to a FHIR resource, the profile also defines some standard search capabilities which a QEDM or a clinical data consumer could use to query a clinical data source, which could be a FHIR server. So it's nothing but a simple transaction where a FHIR consumer is trying to query the FHIR data source. So that's what the IHE QEDM profile provides in a nutshell. So moving on, the other profile what we used to solve one of the problem was the MXD or the mobile cross enterprise document data element extraction profile. So this profile actually provides guidelines on how you could extract or transform the data that exists within the CDA documents, the different sections that exist or the components that exist within the CDA document into a FHIR resource and in a FHIR bundle. So that's what the MXD profile provides guidelines on, mainly from the data extraction or data transformation point of view. So basically, this profile defines in fact two levels of granularity. One is the document level granularity and other is the data level granularity. So document level granularity. So consider an example where I have a patient summary CDA. Via the capability what we built, we actually transform this patient summary CDA into a FHIR bundle or a FHIR document where we have the composition resource and all the different FHIR resources that we have created using the data that exists in the patient summary CDA, and provide this as a FHIR document bundle to the consumer. So this is where we actually have preserve the characteristics of the document, which I will slightly touch upon. So that's the document level granularity, where the CDA document is data level granularity. So there could be scenarios where the clinical data consumer or a FHIR consumer may not be interested in the whole the data that exists in the complete document, maybe specific sections or the components in the CDA document. For example, all the observations related to a specific condition. So in such cases, the service actually needs to provide a FHIR bundle containing only the required FHIR resources that have been asked for. So basically, data element level granularity, meaning we're extracting only certain elements that exist in the CDA based on the FHIR query and provide that as a response to the FHIR consumer. So to summarize the difference between data and document level granularity, document to share and access documents as a composition of various data elements could be attributed to a FHIR document. The other important characteristic what the document level granularity provide is that it provides the context of the care delivery similar to how we have in the XDS world or the XDS documents world. And it also enables or preserves the properties of attestation and the source by providing the options with respect to signatures as defined in the different FHIR resources. And in case of data level, enables access of specific type of data elements, could be observations, medications, immunizations, conditions, etc. that is extracted from a given document and given as a response to a FHIR query. The other actually could be a scenario where based on time span, we just have to provide certain data elements. So in such cases, data element level granularity is useful and comes into play. Okay, now a little bit a deep dive on the MXD profile and how exactly we used it to build a solution. Consider, in fact, the MXD profile defines two actors. One is the data element provenance consumer, and the other is a data element extractor. So when I say a consumer, you could attribute it to be a simple FHIR consumer or a FHIR consumer which has FHIR capability and also would be able to retrieve from the document repository. So when I say document repository here, you could map it to the XDS repository and the XDS registry that exists in the XDS world. The document source actually indicates how the CDA documents have come into the documents repository and registry via the traditional routes, could be HL7 or in form of any other existing XDS-B transactions. So in this particular profile, if you see, there's data element extractor. So what exactly this profile defines is that you have a data element extractor which is capable of reading a given document from the document repository via an XDS transactions, like say retrieve document, retrieve the CDA document from the document repository, transform it into a FHIR bundle, and depending upon the deployment may choose to store it into a given FHIR server or just provide it as a response to the FHIR consumer on the fly. So that's up to the implementers and the scenarios what you try to address on how you would want to build these capabilities together, whether they want to, whether data element extractor can coexist or needs a FHIR server where you want to provide an additional querying capabilities for the FHIR consumers, or just return the FHIR bundle on the fly to a FHIR consumer, where the FHIR consumer using the provenance resource can also get the source document from the document repository. So this is what indicates when we have a document consumer and a clinical data consumer together from the profile standpoint. So this is what, yeah. So summarizing the flow, so the way it works is that we have the CDA documents coming into the document repository via the traditional routes. Their metadata gets registered in the document registry, and using the data element extraction you have the document information, you actually transform it into a FHIR bundle. It's up to you whether you would want to store it into a FHIR server and enable the FHIR consumer to access it, or provide the FHIR bundle. In case the consumer wants the source of truth or the source of information, they could as well query it from the document repository via the provenance. With a QEDM data source, typically a FHIR server, or it also works in tandem with the XDS repository and the registry. So basically, this is the one which is actually trying to bridge between both the worlds of XDS and the FHIR. Okay, so a little bit on the provenance, which exists as an as we know, provenance actually indicates the source of data, when the data was created, and from where, and what is the source and the owner of the data. So from this profiles perspective, how did we leverage on using the document provenance is that within the provenance FHIR resource, actually, there are a couple of attributes. For example, there is this entity what identifier, unique ID, which is typically gets created when you store the document into an XDS, store an XDS network or a system, and the repository unique ID. So one is the system and the other as the value. And that's how you actually build a link between your FHIR extracted or transformed data elements with the source document. Okay, and the FHIR consumers actually could query the provenance via a reverse. So putting all these things together, so this is actually a sample CDA. So in this session, I've actually not touched upon the mapping part, where how and what is the approach we use towards mapping the CDA elements into the FHIR, because that was already covered yesterday. There are multiple approaches existing for that, and so this is how it looks like. You typically have some component and observations. And when I transform this given CDA via the data element extractor actor, we actually get an equivalent FHIR bundle. And appropriately, we also provide the references to the other resources that exist within the bundle. So this is like the normal transformation, what we do. Okay, so now we know the problem, we know the foundation elements, the two IHE profiles, and what is that we did using these two profiles to put a solution together. So now let's consider an example and see how all these things comes together. So for that, actually, I picked up a scenario from the Netherlands markets itself for the Medmij. So please meet our demo patient, that is Rosa. She's actually 54 years old. So Rosa has a history of heart disease, and a few years ago, she also had undergone coronary bypass. She also has type 2 diabetes. So if you see, for a patient like Rosa, there are different data collection points across the healthcare continuum. Could be within the hospital when she was hospitalized, where she would try to access or hold historical reports, and whether it could be home, where Rosa, being a type 2 diabetes, would regularly want to monitor her glucose levels. So how did all the different formats that exist in the variable healthcare ecosystem come together to help Rosa, to self-manage her condition? So in this scenario, so you have the different information systems, which would traditionally be sending the CDA documents via the HL7 route or via the XDS routes. Then we have bring about the data interoperability. Then we have the EMRs and the other systems, which would still continue to send some of the data in the HL7 formats. And yeah, so this is the XDS sources, which actually send in the XDS documents via the IHEs, XDS-B and other routes into the healthcare variable network or the ecosystem. So we have different formats for Rosa to actually access the information that exists. So if you just take a step back and map to Rosa's condition, she would have her historical documents from different information systems in the form of CDA. There could be some information that would have come into the network via the HL7, and there would also be an equivalent of FHIR related reports that exist, which would have come from new systems. So from the patient point of view, so typically what they multitude of storage. In fact, for simplicity, I've abstracted out the connectivity, the authentication, and the other non-functional aspects with respect to integration of these different systems. So for the simplicity of the use case, so now when Rosa via the application accesses her historical reports or FHIR data, which the FHIR app would be able to leverage on and display the same data to Rosa. In the background, the data transformation part from the CDA to the FHIR, HL7 to the FHIR, all those aspects are actually abstracted out from the patient point of view. Similarly, if Rosa actually wants to upload any information that, for example, say a PDF report or some kind of self-measurements, the same could be actually sent via the FHIR apps and then appropriately stored into the data stores. So this is where the other round of transformation comes into play, where we have the XDS stores and we would want to store the documents uploaded by Rosa in those respective stores, where we need to do the other way of transformation from, say, FHIR to CDA. Similarly, once we make the data available in the FHIR formats, either via a FHIR store or via an on-the-fly transformers, it could be even made accessible to any dashboards used by the care providers as well. So that's the scenario in a nutshell, and how we used the profiles actually to solve some of the scenarios. So what's the challenges that we faced during the implementation and other aspects of this? So one aspect is mapping. Yeah, in fact, even though we have a lot of capabilities and approaches available in the form of FHIR mapping languages and other tooling, there were actually scenarios where we in fact could not map the do a one-to-one mapping between the CDA sections or the attributes to a FHIR equivalent. For example, classic would be the null flavors what the CDA comes, and the exact same attribute is actually mandatory in FHIR spec. Most common ones what we faced was with respect to observation, where we have the status and the code being mandatory, but the same thing is actually missing in the CDA. Because it's a null flavor. So that's where some of the problems came in with respect to mapping of the CDA to FHIR. The other would be challenges involved in supporting documents versus the data level granularity. So if the ecosystem has a single document, it's quite straightforward that you could just transform it to FHIR and give out. But what if the patient has, over a period of time, has multiple documents? So how do we go about doing the transformation with respect to historical documents as well as the current documents? At what point that needs to be done? And how do I enable FHIR queries to access data from different documents, yet preserving the source? So there are a few challenges with respect to that, but definitely not solvable. But yeah, we look forward towards the community on some of the aspects on how do we handle multiple documents for us given a patient. Whether we actually provide a gate in the form of authentication and authorization or some other mechanisms, that is something which we are still working on. The other aspect what we faced was challenges with respect to data sync. So if you see in my session, I actually covered two approaches. One was where we have a CDF, where we have a FHIR store, which is actually used as a QEDM data source, where the transformed FHIR bundles were saved, and the same could be accessed by FHIR consumers. In which case, in the ecosystem, you have two different data stores. One is actually the XDS store, the other is the FHIR store. So the data sync, the data lifecycle management across two different stores in a complex integrated network is still a challenge. That is something which we are still working on and not, it's still not yet there. Primarily because on the XDS side, with respect to some GDPR regulations, if there is a need to delete a document, the same have to be, passed on to the FHIR store to delete those information, keep the data in sync. And if we consider the second approach, what I mentioned, where given a document, upon the document arrival, we just transform it to FHIR and provide it to the FHIR consumer upon a query on the fly. So the other challenge there is with respect to the SLAs, where we have to provide, in some cases, this data in real time. So is that a right approach? That is something which you have to weigh depending on the scenarios. As I mentioned, yeah, some of the fields that were mandatory. In fact, there are a lot of gaps that exist between the CDA attributes mapping with respect to FHIR. Classic example could be procedure request, specimen related information, which we still are not able to map into FHIR for some reasons. Yeah. The other aspect would be with respect to creates and updates. So what if the same data comes from different documents? How do you take a call whether when to create and when to update? How do you build some kind of a data merge capabilities? So, and at what level you need to go into to enable, checking the similarity of data to ensure that you are updating the right patient record. Primarily, since we work in a highly regulated and a governed environment, all these things play a very important part, to put all the workflows together and to also maintain the sanctity of the data what you are transforming. Yeah, as I mentioned, data lifecycle management between the stores is actually, it's an important thing which we are still working on. Yeah, and the other challenge is some of the data that exists in the CDA, but we are not in FHIR. We actually provide in the form of extensions. In fact, the CDA spec, that is the 1.1 version release, to very large extent addresses these. Classic examples could be race and ethnicity that exists in CDA. We actually have an equivalent FHIR extensions in the CDA specs. In fact, we could leverage upon that. Is something which we learned it very recently. So that is something which we will try to improve upon. In the other challenging part is if it's a smaller kind of a deployment, all those things, all these different aspects what I mentioned work fine. But what about in a cross enterprise community or an XCA network where we have different communities enabling the interaction or data exchange between the different communities via the XCA infrastructure? So to build all these capabilities, to scale up, to match such kind of data access and exchange is still challenging, but that's something not impossible though. Otherwise, I think we would not have mobile in our hands, right? So yeah, but definitely, that is something which also we look forward to the community to provide us some guidelines on handling all these different scenarios. From the standard perspective, yes, during the implementation stages, we did observe few gaps, and the same also have been reported to IHE framework with respect to say, for example, in the QEDM profile, we actually have a defined set of FHIR resources. Actually, the latest QEDM profile is mapped to R4, and the profile vaguely mentions that you can still use R3, but the resources needs to be normative. Right. So in such cases, like primarily that's another problem where we need to still deal with FHIR versions. But yeah, can we extend the scope of the FHIR resources defined in the QEDM spec? So that was one important aspect. Similarly, there were a few updates needed on the search modifiers that the spec mentioned. So that's something which also have been shared across. Also, some of the we were in fact one of the common problem what we had or faced was that with respect to changing FHIR versions, right? The two specs what I mentioned were initially in R3, and then we also support R4 actually. So what I understood was with respect to changing FHIR versions, IHE will also release an equivalent, the IHE profile specs with respect to newer FHIR versions. However, what about the backward compatibility? Because when we talk about the variable and the complex healthcare ecosystem, it's not always possible that all the products actually use a single or a latest FHIR version. It's an ecosystem where different products use different FHIR versions. Handling those use cases or scenarios, that is something which we still are figuring out. But yeah, in fact, we are looking forward towards the community to help us provide certain guidelines on how we could keep the IHE assets what we create for FHIR in sync with the FHIR versions. So that's one aspect. As I mentioned, changing FHIR versions, IHE profile needs to also still be compliant to older standards, also provide some guidelines towards backward compatibility. Yeah. One of the important aspect is towards handling unstructured CDA. That is something which we started on. That is something which we still need to figure it out and completely build a capability towards handling unstructured data and CDA. And there's definitely something that I take back from the DevDays on these aspects. Yeah, from the mapping perspective, yes, as I mentioned, there are gaps, and that is something as the CDA spec evolves, I think those gaps would be bridged. So yeah, that's all I had for today's session. So just to summarize quickly what we went about today, we just discussed about the healthcare ecosystem, the different variabilities, complexities, different data formats, specs that exist. And also what we learned about the FHIR and CDA, how from the consumer standpoint, irrespective of the data source, we can actually provide the data in a format what the consumer is asking for. We also touched upon the need for data transformation from CDA to FHIR. Then we learned about the profiles which we used as a guideline to build these capabilities. Some of the gaps during the process of creating these assets were also shared with you in terms of challenges and improvements. To summarize all these things, we also went through a quick example on how we could go about using all these assets together to build a solution where we could actually improve better care and provide a little more control to the patients, in terms of the data they access, and also be an integral part of their care journey and their decision making process. Yeah, so that's all I had for today, and these are the references that I used. So I will share this with all of you. If you can contact me, yeah, you can contact me on LinkedIn or via the app provided for DevDays. So that's all I had. Any questions?
Great, Revathy. So you're perfectly on time, to the minute. I didn't have to pull up my slides. One question I've got here is, do you have an example of a search modifier that needs to be updated?
Yeah.
Can you hear me?
Yes, Gustav, I hear you now. Yeah.
Okay. Do you have an example of a search modifier that needs to be updated?
Yeah. Just give me a moment. I think I am not able to hear you well. I just look into the questions. Maybe just give me a moment.
Okay.
Gustav, can you please repeat that question? Maybe I'm not able to hear you well.
Okay. Do you have an example of a search modifier that needs to be updated?
Yeah, the date modifiers. So typically the QEDM profile defines a certain search parameters with respect to date, and also the search modifiers which could be used. For example, you want to use a date range search as the FHIR spec defines. In fact, there are different modifiers for that. So there we, in fact, that would be a classic example with respect to date. The other example would be if you see with respect to the Medmij specifications itself. In fact, there's an operation actually which is defined with respect to getting the last few records called as the last end, right? So yeah, with respect to operations and modifiers, yeah, these are some of the examples that I could think of on the fly as of now. But definitely, I would be able to I'll be happy to share with you a few more what we have come across. I just need to do a quick look up on that. Yeah.
Okay, so it was specifically search modifiers which need to be updated, not date modifiers. So search modifiers.
Sorry.
So that was specifically search modifiers, search, not date modifiers.
Yeah. So in fact, when we say search modifiers, date is actually a search parameter. Modifier for a date would be, something like a greater than, less than date, or some the spec actually provides on how you could use these modifiers to do the range-based searches. In fact, I just can't think of the fly, but I will definitely share those things actually on the search modifiers for the date, for the specifically for date, because that is something what we actually came across. So yeah.
Okay, so maybe to a totally different domain. So could you point out use cases where where fine-grained access is really important in this context, where you'd actually justify the investment in this context? So where fine-grained access by this approach in a clinical case is really makes the point for this investment.
Yeah. So typically, it's up to you on how you would want to go about approaching it. But considering our case, the way we work about is that we actually pick a specific use case or a need that is coming in from different markets, and that's how we apply on how we exactly meet that particular need. In fact, we don't first go about looking for, okay, there is a capability called as fine-grained access which could do the transformation. In fact, it's the other way around. We actually start with the need and see in the umbrella or under the umbrella of interoperability, what is that which actually best fits that need, and based on that actually we pick it up. So in this particular scenario, what I mentioned, the need was actually to enable data access to the patients, but the problem was the data existed in XDS infrastructure, and we had to build a capability to enable this data access from these existing infrastructures to a modern way of accessing the data via certain FHIR apps. My apologies, I'm not able to hear the questions properly because of some network, but I will definitely read through the app and I will answer all your questions.
Okay. Okay, maybe we take one more question, Revathy. So, yep. So most hospitals are thinking whether they really should invest in IHE infrastructure, since some of the most common profiles are actually represented in FHIR, and these cases can be handled by FHIR technology. So what would be your take on that? Could you actually cover the IHE use cases using a FHIR stack technology and completely making do without an IHE stack on premise?
Hello?
Yeah, okay. So I think we do have some sound issues here. So the question was whether, seeing that most of the IHE profiles are being translated or are being made compatible to FHIR. Okay, I think we have an issue here with the sound, so I think we'll follow up with these questions in the chat.
Yes, yes. Yeah, because in the app, I actually see one question, that is, do you have an example of search modifier that needs to be updated? Yes, I will. I will share the details with you. In fact, that's what we had given to the IHE spec as well. But I don't see the other question, Gustav.
Oh no, that's what I was just asking. I was just asking that question myself. Okay.
Okay, okay. Yes.
Good. So is there something you want to add, you'd like to add to you'd like to comment on to your talk?
Okay. Yeah, so maybe I actually have some issue with my bandwidth. I'm not able to hear what Gustav is saying. Please reach out to me if you have any questions. Right. I would be happy to share our experiences with you. So Gustav, I will touch base with you on your questions. Just that it's breaking and I'm not able to interpret the whole questions. Okay. But yeah, please reach out to me if you have any questions. Yeah.
Okay. So thanks a lot. So please, to the others, post any questions, follow-up questions you have, and also remember to rate the talk. That would be great. I found the talk very, very interesting, and I'll certainly follow up with further questions. Yeah, so thanks a lot. Since the sound is breaking, apparently, so you came in through quite well. The sound broke a bit, but it wasn't worth switching to phone. But apparently the upstream connection seems to be less optimal. So I think we'll leave it at this. We just got 2 minutes left. Thanks a lot.
Yeah, thank you. Thank you.
Yeah.
Thank you.
I'll stay in the call for the next 5 minutes if any follow-up questions come in, and I'll just type in my follow-up question in the meantime.
Yeah, sure. And I'll connect via the app and I'll try to answer if there are any questions. Yeah, thank you.
Great.
Yeah, thank you.